Hello? 1 second, just checking things real fast. Hello? Hello? I think I'm good. Alright, I think we are set up and running. I just want to make sure everyone can hear me okay. Yep, seems like I'm coming through. I think we're set up and running. Alright, cool. Yep, sounds like we're good to go. Alright, cool. So welcome everyone. My name is Ian Boyd. I am a university library specialist at NC State University. And I'm going to be talking today about TouchDesigner and kind of in general creative coding as a whole. So I think it'll be a pretty good time. Hold on, let me make this bigger. Okay, cool. So in general, yeah, what we're going to talk about today is we're going to kind of talk about just basically what this software is, what it can do. I'm going to try to show you a bunch of examples that I think are pretty cool, both interactive and otherwise. Both examples of generative art, creative coding, just a whole range of stuff. So I kind of want to get started and kind of talk a little, and then we're going to talk a little bit about the software. Like what is it, what does it do, all those kind of things. So just to start with, I think this is a pretty good example. Let me get this going. So, and this is kind of a good microcosm of what TouchDesigner is and kind of what it can do. So I guess basically what I would say about TouchDesigner as what it is a node-based coding language used to create real-time graphics. And what does that mean? Well, I think we'll get into it a little bit and you'll kind of see it in a second. But basically what I have here is right now I have this big fuchsia square, but I can make generative art with it using some noise parameters that I've created here. So if I pulse this and restart the simulation, air quotes, you'll see that we get some pretty cool effects. And this is all being conducted generatively, and it can be controlled by a number of things. I think this one's pretty beautiful, so this is the kind of one I start with just to begin with, because it kind of showcases like the kind of graphics that you can create here. And then what is this doing? Where's this coming from? Well, we've got a big network here. So basically, not big, it's actually fairly small for a TouchDesigner network, but this is basically what we're using inside of here. And if I'm honest, we don't really need these nodes, I think. I think most of what's happening is happening right here in this section. So it's not very much at all. But it gives a good example of like kind of what TouchDesigner does, like what it's good for. So real fast. Let me refresh this one more time. Pulse. Yep, there we go. So to start with, we have a base noise parameter. This isn't what I'm used to noise looking like. Usually noise is like all black and white like this, but this is a colored noise. And then we run it through itself to create some distortion. And then we displace it based on this animated noise. And as we do so, let me see if I can show you early on. When I click this pulse button, so pulse, you'll see that it's a pretty good example of what we have here. But what the feedback and the displacement is doing is looking at the color value of every pixel, the RGB value. And it's saying, okay, if these two are pushed up against each other, they're gonna like kind of go towards the strongest average. So if we pulse that again, you see, so like we've got lots of colors, but as soon as they make contact, you see they kind of flow into each other, and then we get an average color. So like some of them are competing for it, but eventually this one kind of takes over right here and they push through. But we're also generating these like kind of wave diffusion patterns because we're doing it on a pixel by pixel basis based on this noise. So every time something changes in a pixel value here, you kind of see it replicated across the noise that's up here. So basically what it creates is this very cool like kind of ink in water effect. And all this is doing is just to give an example of how you just took something like this base noise, and by running it through, you know, a couple of filters, a couple of nodes, all of a sudden you get something that looks really cool and really interesting. So I just wanted to kind of show that. So one more time. Oh, beautiful. And what I'm going to do today is I'm going to kind of intro you to TouchDesigner through cool examples. Like I'm going to show you interesting or cool examples of what we're doing in the software, what the software can do. And we'll just kind of go from there. So I wanted to start with this one. It's actually pretty simple, all things considered. And we could adjust these parameters to, like, well now, you won't see it take effect until you pulse it though. But like now we get like much more mixing, lots more colors because it's all being derived from this. The biggest change would be as if we messed with this one. Again, so let's turn these harmonics way down. So we have something really blurry now. Watch what this looks like. So again, we took what was very grainy and made it very blurry. You're already seeing it a little bit, but watch this. You see the effect is a lot more diffuse and a lot more, I wouldn't even know what to call it, melting crayon than it was before. Like before it was ink, now everything looks all viscous. But basically, these all have just a big impact on it. We could also see, because now the values are more constant, because I've kind of taken it down so everything moves more slowly. And we could even go to the point where everything's pretty much frozen. And then we could advance it again. And all this is being done in real time, right? See, and like now we have like these hard edges. Yeah, all kinds of cool stuff. And then we can always go back to it. And like I said, all this is being generated in real time, right? Like, so this isn't being rendered. This isn't like a render thing. It's literally like taking the noise and going from there. So let's see. And like what's cool is that in TouchDesigner, this could be driven by anything. Like it's not necessarily something that has to be from this noise parameter. Or what should I say? Pulse that. Turn the harmonics back up. Yeah, there we go. So basically, like you can see as I make these adjustments, they're done on the fly. And I don't know if you see up here in the corner, but I'm running at a stable 60 frames per second. And TouchDesigner is very good at utilizing your CPU and GPU resources effectively and keeping you a very nice and concise, like stable frame rate. It's really good at it. And you know, you don't have to stay at 60 FPS. You could like drop it down to something else or keep it, you know, like higher or lower. But generally it wants to run at 60 frames a second. So just wanted to start that. This is a pretty simple graphics example, but it kind of gives you an idea of how you can kind of change these things around, how they update in real time, and how you could do some cool graphical stuff just like right off the bat inside of TouchDesigner. This is 2D, but we can look at other examples. Let's see what I got in my folder. Let's see, infinite space, looping noise, paint noise. Let's try looping noise. Let's load it in. All right, cool. Here we go. So you kind of see what you got here. I wonder if I can, let me see if I can get a preview looking. Nope, not this time. Just checking. Yeah. So you see what I've kind of got here is I've got this kind of infinite tunnel that I'm going through, and what this is to show is just that basically this will continue forever if you let it. And an example, this is a good example of channel parameters. So before we were using mainly texture parameters or texture operators. Now we're using channel operators to basically generate this infinite looping tunnel. And it's not infinite. Technically it's a circle, but an interesting circle, I guess we'll say. So the idea is that we have this circle right here. And if we pick a point on this circle and draw another circle within it, and we put some kind of noise on top of it, if you go around the radius of the circle, every value that you hit along the way, hold on, we can do a visual example. So we'll make this noise, a circle, and comp them together. Cool, it's like this. So like, let's say you have a circle made of noise, which is basically what we're generating here. So it's just a circle, like the noise can be changed at any point in time. You know, if I just get a different seed, the noise can be different. We can have a bunch of different seeds. But all we basically have is a pixel bitmap of a bunch of random values, right? And since that we're using geometry to get here, so like let's say if you start at this point on the circle and you go all the way around the circumference, and as we go around the edge, it's looking at these pixel values and it's displacing them based on whether they're black or white, right? Like whether they're 0 to 1. So it's using that to function in the displacement. But as you go around the edge, you'll notice that we're going through all these things, like the tunnel's distorting, like all over the place. It's moving back, it's moving forward as we kind of move forward. But as we come back to where we started, it's going to have to loop because the noise hasn't changed at all. Now, this could work differently, right? Like we could animate the noise or something like that. So transform, just use a quick function. ABS time dot seconds times, I don't know, 1, whoops. That's what I was doing. ABS time dot seconds, not an F, times 1. So we could like animate this noise, okay, and then this is no longer true, right? Because now the noise pattern is changing every frame, and like it's not going to be consistent. But if it's not animated, and it doesn't have to be, you know, this is always going to be stable, and we're always going to kind of return to where we started. So just the important thing to remember here. And then we can use that and modify it in some ways. So like we're creating this circle right in here that is being, you know, beamed across to make our tunnel that we're moving through. But we can use these noise values and channel values to basically displace it and kind of create what we're looking at here. And we have a bunch of different operators in here. I just want to grab some stuff real fast. Like if we move the range, let's see. I don't know if you can see it right now. It's kind of updating as you go. But if you were able to zoom out, you'd see like it'd be pretty wild. Let me see. Yeah, here we go. We'll go back to this. So this is the loop that we've made, basically. So we're not going infinite through space. We're just going through an infinite noise distortion as we run through here. So like, all we're doing is just generating this infinite path based on this noise circle data. And let me see if I've got, like I said, whoops, going too far back here. Yeah, exactly. So here's our line that we're generating, and then we're just displacing circles around the perimeter of it to generate this, which we can then fly through by animating our camera. So like I said, there's just a lot of cool stuff that you can do within TouchDesigner, and I'm just like going through to pull examples. In a little bit, like we'll start making stuff, but I wanted to show some cool things first that I've been working on or making. So we'll go from here. Let's see. Generative topo, this is a good one. So this is kind of a 3D example, but we're going to go to another one real fast. If we can get it to load here. If not, I'll just restart. TouchDesigner is pretty quick on the restart. Oops, sorry. Sorry if I'm blowing you out there. Well, all right, one sec. Let me just open this another way. Cancel. Generative topo. We'll get back into it. TouchDesigner is really good at running one project stably, but sometimes it's bad when you're like switching between them. But here we go. So we've got this up right here, and this is basically a generative world that I've created. It's 3D. You know, you've got a light in there. It's displacing. I can change like where the light's looking. Just, you know, like this is a 3D object, right? So we go from here. And what you can do is, because I'm generating all the maps for it generatively, you have all these parameters that you can use to change it. So really everything is just based on this one noise function right here. Like all this displacement, all the color, you know, like all the topology is just based on this noise. So if I come in here and I start modifying my noise parameters, you can see that I can change the landscape, like based on how we go. So like now we have almost no water. You know, we can go all these mountain peaks. We'll kind of take it back towards our baseline. You can mess with the amplitude to create more displacement, these giant mountains, or bring it so everything's very flat, perfectly flat world. You can change the offset for more or less water, you know, more land, less water. Through here, you can change the harmonics. So like maybe this is too simple, you know, this is too simple of a topology. Well, now you have a very detailed one, and you can even change that even more, right? Like this is a little harsh, but like maybe that's what you want. And then we can take things like the exponent down, you know, so it's not as like hard and the edges aren't as jagged as it comes out. But basically all these nodes are just being controlled inside of here. And we can take the period up or down, create the scale kind of the landscape we're looking at. So if we want something more detailed, maybe drop the exponent down at this point. You know, you can kind of create this sort of landscape. Take it up. If you want to create this giant, like, you know, very flat topology, and you can go even higher, right? Like I can go to 5. I'm not really bounded by this. Yeah, look how big that is. So just kind of showing some of the stuff you can do generatively to create things with it. Like I said, generative graphics creation is really what we're looking at here. Take the period down from there. Now we have all these little like tiny circle lands. And like all this can be just modified, you know, like at will, kind of as you go. And all this is being driven by is all this noise is being turned into maps. So I don't know if you're familiar with 3D art that you can do things like normal or height map things. Well, I'm doing these on the fly generatively inside of TouchDesigner. So I've got a normal map here providing detail. I've got a height map here that's actually providing the displacement. And then I have my geometry itself over here. Let's see what we turn on. Yep, over here, that's the actual geometry, which being derived from the sphere, and we're just displacing it in real time to kind of create this effect. And right now I'm controlling it by just moving the sliders around, but again, like I could control it with anything, right? Like I could plug something else into it. Let's see, like let's pick something, like maybe an LFO. LFO stands for low frequency oscillator. So we have something moving back and forth between a value. Right now it's going from -9 to -1 to +1, but we could put in a math and remap that value. So we could go maybe from 0 to, instead of going from 0 to 1, we're going from -1 to 1, and we could go to the range maybe 1 to 2. We'll see in a second. Okay. If this is too much, we'll see. But then what I can do is I can take that. Remember we had this period that was kind of scaling things up and down. Let's see where we go. Maybe 0.2. 0.2 to 2. This is going to look a little wild to start with, but it's okay. Well, we can use this to drive this setting, right? So I could say up, math 1, chan 1, or 0, in brackets. And then what we're doing is we're driving the displacement of it via this low frequency oscillator. Now this is going a little fast. Maybe we slow this down a bit. Whoop, whoop. But you can see we're now displacing the entire landscape based on this other channel value as it comes into play. And we can adjust the other things still, right? Like we still have like control of them. Like here's our harmonic gain, you like coming in and out. But like the period is always going to be scaled up and down. And this doesn't have to be an LFO, right? Like I just used an LFO because it was like an easy thing to give an example of. Like it's going to move back and forth, you know, and kind of create this motion. But it could be anything. Like I could use another noise, you know, to generate it. So like, let's grab a noise channel. Let's see, just get a noise here. We're going to animate it on the x-axis. So ABS time.seconds times, I don't know, 10. It's too slow. Let's go faster. Times 50. That's probably good. And then by the default, we'll just leave it here for now. 1 second. I'm going to time slice it so we can use it. And then instead of going from math 1, we're going to go noise 2. So change this. Noise 2. You see this is flashing. We probably should use a math. That's a little wild. Going too low, because if it goes negative, it doesn't know what to do with itself. So let's break this. We'll connect the math node. And all we're going to do is change that range, right? Like we're going to change the range from what we have right now, which is, let's look at, turn off time slice for a second. It's like we're going maybe like -0.5 to 0.5. We're overshooting that a little bit. But that's around what we're shooting for. So we'll say -0.5 to 0.5. I'm actually going to push that up a little bit. We'll say -0.8 to 0.8. Just because we're overshooting that sometimes. We're going to turn that from range, yeah, 0.2 to 2. Sounds good. Now we can map that to the period, math 2, whoops. So OP for op. Then you put in a string, which is the name of your operator, math 2. And then the channel that you're using, which in this case is channel 1, and we're using the 0 index, you know, 0, 1, 2, 3, 4, 5. So we'll put it in. And now you see like it's just going to move up and down pretty fast. We could actually just turn this down too. It's going faster than I gave it credit for. So instead of translating it times 50, let's go just times 5. Even that's pretty fast. Hold on. 1. And you can see that up here it's being driven by it. So sometimes you're going down to 0, and that's when you kind of get these pauses in here, but I'm just wondering. OP Math 2, channel 0. And it is moving very slowly, if you can see right here. Oh, yeah, the range got messed up. Okay, no wonder this isn't working. Negative 0.5 to 0.5. So negative 0.4. So yeah, just updating my values just to change like what happens. So go from -1 to 1, and now we have this like infinitely scaling back and forth thing that's based on noise, right? Like I said, and this doesn't have to be, you know, the period channel. Like it could be any of them. Like I could grab this same thing. Let's take this out here. Change it to a value like, I don't know, like 1. I could grab this and put it in something like the harmonics, you know. I could drop this in here. It's funny though, so this is going to be an int, so it's not the best example, but you can see how it's going to like toggle back and forth between it. All right, so let's take that down if it's going to be an int. No real reason to do that. But a harmonic spread would work, right? Because that's a float. Ooh, that's a little much. All right, seizure warning on this TouchDesigner stream. Go back down. Like the exponent. Yeah, it's a little better. Not going so crazy all over the place. So right now, basically just showing that we can drive anything inside of TouchDesigner using any other variable. Like I could take this and loop it back into itself later along the way. So just kind of showing this generative world that we went through, and then just kind of showing like what that looks like. Let me see what else we can show real fast before we get into making stuff together. What do we got? Looping noise, paint noise, infinite space. What is infinite space? Hold on, I just want to see. I think I know, but maybe I don't. Oof. Oof. That's too loud. All right, hold on one sec. Sorry if I scared everyone. I'm going to toggle some settings real fast. Desktop audio. Maybe the desktop audio is not coming through for you all. I hope not, because it would be very scary. It scared me. I was playing this infinite noise one, and it's too loud on my end. Let's see. I'm going to check out the levels here real fast. Let's see. Mute this. Mute this for you. Mute the desktop audio. Okay. Now what's this sound like? I'm just looking at my levels real fast. Make sure we're not exploding anyone's ears. Okay. That's not too bad. Pull them down maybe a little more. Okay, cool. So I think we're good. Let me turn the desktop audio back on. All right, nice. So this is a infinite scroller, but it's also audio reactive, I guess is what you're seeing. So like I said, you can drive the motion of things by anything. So in this case, we have an audio track in. Let me turn this down a little bit. Make that pretty low. All right, cool. So you see that we've got this audio track in that we're looking at, and it's analyzing the waveform, right? And then it's using that to displace these pillars that we kind of have in the surrounding scenery. So what you created is just this generative, you know, kind of piece of artwork that's audio reactive. And TouchDesigner is really great for working with stuff like this. Let me see. Let me come back to my stream here real fast, make sure that I haven't killed anyone with the explosion of noise coming out. And what we're basically doing is generating an audio spectrum that we then use to displace everything. So this is our field of noise. And this is actually using a technique called instancing, which is pretty interesting because basically what we're doing is we have this noise function. And for every pixel in this noise, we're basically generating a square, like out in this field. So all these squares are being generated from this texture right here. And then the displacement is being done across all of the squares in time with the waveform. And then the infinity comes because we're looping through the scene using these two ramps. Let's see. This one here and this one here. So it's just a really, kind of cool, trippy visual as you go through. You can also modify things as you go. Like I said, all this can be updated on the fly, like we're working in real time here. So I go landscape, like the transforms I could mess with here. Like if I take the scale up or down. Yeah, get much higher. Take the uniform scale up. Things like this. These are all things like you can modify or mess with on the fly. And this was really strong about TouchDesigner. Like if you were rendering something out, like in a traditional 3D application, like it could just take forever to render out this kind of stuff. But in TouchDesigner, it's done like pretty quickly. So I just want to kind of just show everyone that. And there's lots of audio reactive things that you can make inside of TouchDesigner. Like this is just one example, but I did want to kind of show them when I went through. Yeah, let's see, what else? I think maybe it'd be a good time to kind of like come to a fresh canvas and kind of talk about some stuff, and then I'll come back and show you some more cool things. But let's go ahead and make a new one. Yeah, we'll just quit. So we're coming back around. Cool, cool. So if you have a blank canvas, we'll start making a few things in TouchDesigner. The first thing that you want to know is that inside your workspace, everything is almost done exclusively through nodes, which in TouchDesigner are called operators. So if you hit Tab on your keyboard at any point to generate stuff, you'll create this OP Create dialog box. And what this will do is it'll basically give you a platform for all the different operators that you have inside of TouchDesigner. And they group them into different categories, which I think it actually serves really well because I've used some other node-based programs in the past, like things like Substance Designer come to mind, things like geometry nodes in Blender, or like Unity shader graphs and things like that, or VFX graphs. And they get a little overwhelming because everything's like kind of in one big list. You can usually sort them down, but TouchDesigner I think does a really good job of making this like visually readable and visually appealing. So here, I'm just going to run through the different categories we have really fast. We're going to leave this one out for now. But you have tops, which are texture operators. These are 2D things that use bitmaps primarily. Chops, which are channel operators. So they're using channel wavelengths that you would generate from like a musical instrument or from a stream of data. Sops, which are shape operators. So this is three-dimensional stuff, three-dimensional rendering, like polygon rendering, things like that. Mats, which are material operators, and these are basically if you want to texture anything, whether it's a 2D plane or a 3D object. And then DATs, which are really strong, which are called data operators. And then data operators, basically, like the name says, use streams of data from a source, whether that's a sensor or it's an API, that you're pulling from. DATs can make it very easy to create things with large swaths of data and make very cool visualizations. So DATs are also super strong. And then coming back to the comps, these are kind of your organizational tools. So a comp in general would be like grouping everything into one like folder or file. So it's just basically at the end of the day, it's an organizational technique. All right, cool. So we'll just kind of show like a basic process like to make something inside of TouchDesigner. And it depends on what you want to create, right? Because there is like a bunch of possibilities for making stuff inside this program. I hope you got like a little bit of it from just like everything I was showing you so far, but like there's a lot you can do. Well, maybe go through like a traditional like 2D or 3D workflow. We can go from there and see. Maybe we can instance something. I feel like instancing something is always fun. So that'll be a kind of a combination of a 2D and a 3D network. So to start with, we'll go for a SOP, service operator, and we'll make something like, let's say, maybe a sphere on here. And then what we can do is we can displace it with some noise. So basically what this is doing is just displacing the points randomly using a noise function. Let's see, we're at a mesh, polygon. I just want to make sure we're doing the right one. Detail. Yeah, so we want a lot of rows and columns. We'll say 40 and 40. So you notice as we add more, it gets a little smoother. If you take them away, it gets a little more janky, a little more jagged. But we want it smooth for right now. We want a lot of geometry on this sphere. Okay, okay. And then what we want to do here is we can take this. I'm going to put a null on the end. A null is basically nothing. It's like an empty object or a placeholder. And it's like, why do I put nulls on the end of things? Well, it's because if you change anything, like put something else on the end, like you want to add another operator, you're going to have to relink your network, right? Like, because remember I was referring to things by name. So if like I referred to noise 1 and then I'm like, oh, you know what, I really should translate that, right? So I can insert an operator, translate, or transform. Yeah, transform in here. You can put in a transform. All right, well now I've kind of broken the thing because I want the end, like the end result of all these nodes. And by adding this transform, now I have to go back to whatever I've referenced, you know, like take out noise 1 and then put in transform 1. So it's good practice just to shove a null on the end of every, you know, like kind of string that you make, because then like no matter what you change, like the null is always going to be the last thing because you're not going to change things past the null. So best TouchDesigner practice, put nulls at the end of these lines. Okay. So now we're going to make a geometry node. That's actually a comp tool because you're comping the geometry together. This is your shape and you're comping it into a geometry. Whoops. Don't know how we got that. Let's grab this. Go back here, geo. Cool. So there we go. We got our geometry organizer. It's stuck in there. All right. What we're going to do now is we have this instancing tab up at the top here. So we have an instance. We can turn that on or off. Right now it's not doing much. Let's say we made something like a box, a cube, if you're in literally any other 3D application. I think what we're going to do is give the box its own geometry. Geometry. Cool. And we're going to use this geometry to drive this. So how does that happen? Well, we're going to take instancing and place the default instance OP. So we're going to instance box 1 on top of this. So we get that connection. It's going to be like, okay, but how do you want to do it? We'll say translate X, position 0, position 1, position 2. See, now it's going around that. See, we can also do it the other way. So like you see we've generated 4 things, 1 for each point in the box. If you look at it, you can see we have different 4 shapes in here. What if we do it the other way? So we'll take this one out. And we'll say Geo2. Oh, sorry, you can't instance itself. We'll say nothing for right now. We'll just keep it at box 1. But over here, we'll instance this one. And we'll say, yeah, we'll turn it on. And our default instance OP is going to be Geo2. Let me break this one real fast so they're not instancing each other simultaneously. Turn off. And by Geo2 I mean null 1. Sorry, you can't reference a comp in the same way. Okay, so there we go. So referencing null 1 and then our geo, and we're like, okay, so how are we going to do this? We're going to use the translate option, and we'll say 0.0, 0.1, and 0.2. And if you look at that, that's crazy. Well, for starters, it's just way too big. So we're going to insert an operator. Right there. We're going to do a transform. We're going to scale this down. Like this. All right, there we go. We can scale it down here too. We can see what we're looking at. Now you see that we've taken every point, we've taken every point that's deforming here, and we've applied the mesh, this box mesh to it right here. So we kind of have this like particle effect almost. And we can make it, we could use more too, like, so because it's based on the number of points in the sphere. So right now we can bump this up to something like, I don't know, 100. That's actually kind of cool. So let's take this back down. Something like 20. Yeah, so like generating this. So like, you know, like now we're generating this basically based on these rows, right? Because we have way more rows than columns. Of course, we could also just put them up the same and make this super dense shape, right? That's all made out of squares. And this doesn't have to be a box, right? This could be any, it could be any shape. I think you could honestly instance it against itself, although that sounds like it would make my computer die. But we'll take the box out. Like, no, we don't want to do that. But we will do spheres. So plug that in, and now, same thing, except now everything's being done with a huge variety of spheres instead of the boxes. And if we could do this, we can transform them on the fly, right? Like we could take the scale, maybe on the Y, and go, we're gonna scale this up. And now you're each doing it with these like big, giant, you know, like tall spheres. And again, you can just move it down. don't go it so far that it disappears. What was I saying? But yeah, I mean, like you said, you can generate anything about this. And again, if this is too big, you can just turn the scale down. So 0.01. And so now we just have these really tiny like ropes of spheres. And you'll notice that I'm still staying, like this is a lot of geometry, right? But I'm still staying at a consistent 60 FPS like the whole time as I go through. So just to kind of demonstrate like some of the things you can do. And then you could also run other things into it. So right now I'm just doing a translate OP. I could put in a rotate op, a scale op. And they don't need to come from geometry either, right? Like I could do this with a texture. So we go noise. Go ahead and put a null out here, so I'll probably need to change it. I'm going to look at the number of points I have. So 100 by 100. Let's change the resolution of 100 pixels to 100 pixels. And then we're going to animate this. A as time dot seconds times, I'm going to say 0.5. It's a little slower. Okay. So now we have this in its motion and it's animating. So we already have something driving the position of all this. Well, we could also have something driving the scale, we could say. So I could say scale OP is going to be null2. And instead of P0123, P012, which are the texture points in space, X, Y, and Z points, we can say, okay, instead let's use the R, G, and B values. A second, I'm going to hit up my thing. It's probably because my resolution is the wrong size. I just want to see. If you get an error like this in TouchDesigner, you can just hit the info button. Yeah, same number of instances. Okay, so 100 by 100. 1 second. Something else I could do that helps me out sometimes if I'm like looking to make sure my things line up exactly. And then it has to have the same number of instances because you need to make sure you're displacing each one equally, right? So like every one of these points needs to equate to one of these points on the texture. So real fast, I also just want to make sure that I'm not driving it all via null1 up here. So say null1 down here. Okay, this should be good. If you want to find out how many points you have, you can always convert it to a chop. Looks like we have just shy of 1,000. Start end 0 to 9801. Okay. And if we put this one through, not the sphere, sorry, the texture. Chop, top to chop. You can see here we only have 101. So we're going to need 2 sets for each one of these. This is kind of the mistake I'm making. So let's try this. Common. So make sure we get our chops to line up. So we have 1001. And over here we have A little bit shy of that. 9801? Okay. So that's what we're going to change it to. We'll probably just have to go down in this because we're gonna run out of room at some point. So let's knock this down to like, I don't know, 20 by 20. Cool. There we go. Then we can see we have 361, 0 to 361. And it's not entirely the same because if the rows and columns are different, because there's like a different spacing on the crowns and stuff like that. So that's where you get some variation in the changes. So 0 to 1, what was that, with 361? Okay. We're gonna go to our resolution. We'll say 360. Might be 361, I just want to see. Okay. $361. All right. Oh. All OPs must generate the same number of instances. Yeah, that's what I'm trying to do. Let's go info. To make sure. 362 points. So let's try one more. 362 by 362. Okay. That's what I'm getting struck with. Did we change it here at all? I'm just going to look at info. 420 vertices. That could be the difference. Sorry. Just going through, making sure I get everything right. Hey, there we go. Got it. For a second. The other thing I might be doing wrong is I might need to put in a polygon. Ooh, that's beautiful. Okay. 1,000. Oh well. I just want to get it through. But yeah, basically you have to make sure that you have a texture resolution the same size as the number of points you have in your sphere. It's a lot easier to do this on a grid because they just like line up. So I could just take this sphere. Whoops, not that one. I could just take this sphere and just say, nope, get rid of that. We're going to do a grid. Just because the geometry is like slightly different. So we have this grid kind of warping around and stuff. If you look at this without this real fast, we can just take this off. You can see it kind of waving around, like as a grid do. But here, it's very easy for us to say, okay, let's say 100 by 100, right? A lot of distortion. And now we can take the scale parameter and say, okay, I know this is going to be the exact same because a grid works the same as a bitmap image, 100 by 100. We can say null to. And there you go. So, like I said, I'm just bad at finding the right number of spheres, but now what we're doing is basically we're driving the translation via this noise parameter, you know, up here that's waving it around, but we're driving the scale via this bitmap image. Like, let's pull this up real fast. Hold on, we'll make a render. Render. It's giving me an error, and you know why? It's because for rendering we need a camera and a light. Okay. Cool. We'll zoom in a little bit. Get a little more close to our topic. There we go. Okay, you kind of see everything up there. Oh, And then in our camera, we want to say not all geometry, or in the render, not all geometry. We just want to do Geo3. Because what we're getting, you'll notice that this has holes in it, and this one doesn't. It's because these are like right on top of each other in the render. That's what the camera sees. So instead of saying all geometry, and if you use that in TouchDesigner, a star is that little placeholder. You can take that out and say Geo3. We only want to render this one. There we go. Then we kind of get this example of what we're making. And the really reason I did that was to throw this in the background to kind of show that if you look closely, you can see that where these periods of emptiness are actually kind of where these black patches are moving through. Because the scale of those is going to be set to 0, right? And no scale means you can't see it. It's just too small to see. So what we can do here is now we can modify the frequency of this noise, or the pattern of this noise. We can say, okay, maybe we could do a smaller period, something like this, right? And then you can see like we got more variation in here. We could bring this up. We could clamp this. Let's see, like this, right? And you kind of see how we're like generating these kind of graphics as we go, and we're using multiple things, right? We're using a bitmap and a mesh, to drive this kind of visualization. And this should give you a good idea of kind of what is possible inside of TouchDesigner. Like, what are you making and like what are you doing in here? The same thing. You can also turn the transform down a little bit. It does matter because it'll give us our base point for it. So 0.01. Yeah, there you go. And then let's see what other shapes. So you can just like keep scaling down like this. Scale up. Again, introduce some variation and scale in there. Make everything very soft, very soft transitions. Kind of adjust how much black versus how much white is in the shape. Do we want very little? Do we want a lot? We can decide, and we're doing it in real time, right? Like that's the advantage, is we can run all this in real time. And if we see, we have these chops up here. Let me see. I'm always sometimes nervous. To run like audio stuff inside of TouchDesigner, but I think I can do this. Let's see. Analyze. Okay. So this is going to kind of explode. I think it's fine. It's not merge, it's combine. Composite. Grab that. Grab that. Interesting. Okay. Like I said, you can use these against each other to like create your audio spectrum, right? Let's see what this sounds like. I think this is just might be like noise on the audio file, the default. What do we got here? We can listen to it too. Yeah. Oof, loud. Sorry about that. All right. It was just a default sound file, music file, track file that came with TouchDesigner. So just putting it out there. But we can analyze that and kind of get these waveforms. You notice how we're kind of bouncing in time with music. Dum, 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 dum. It's also picking up lots of low frequencies. I don't know if you can hear that like with your headphones, but like boom, 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 boom. It's really shaking right there because it's a lot of bass. But you could use this to drive it too, like the displacement. So just audio is just a good example of like how you can really take advantage of that. So just wanted to show that for a little bit. And again, you have these noise values. They're kind of animating against here. You can animate the noise values too. You can say LFO. And then we can just use this to drive the exponent. Let's hook it up to a math real fast. Range 0 to 1, to range. I think we'll keep it 0 to 1. We'll say -1, -1 to 1. Okay. And then we'll say, which one of these is going to give a good result? Exponent's a little boring. This one's kind of good. The amplitude. Okay, we'll put it on the amplitude for now. So say just OP, parentheses, asterisk, math, 1, because it's a string, 0, because we are using the first channel. You see now, again, like it's gonna animate this. So it's like, it's always the sequence, you know, that kind of comes down, where like you're gonna animate this to drive this, which is driving this, you know, and then that now you're thinking with TouchDesigner. Like this is kind of the crux of TouchDesigner, is that, you know, you kind of just take all these things and just drive them against each other. So just wanted to show that, kind of give that example. It's just something like to think about, like as you create stuff. It's just like make sure that you know that you can drive stuff against each other. So 1 second, I'm just thinking about what I want to do next. I think I want to show something I was working on earlier. Let's see. Let me see if I can pull it up real fast. Is it under here? Here we go. This is a pretty good one. Okay. So thank you if you stuck with me for this point, but we're going to try this endless replicator experiment. Let's see. I think I might need the files. Hold on. 1 second. I can fix this. Well, this is going to be pretty cool, but I'll need to bring in the source files if I want to do it. Basically, it was going to be, you can kind of see it without it, right? Like this was the idea. So this is just squares. So it's a particle effect, which is, it's cool. It's cool and all. But what I was doing with it originally is there's this Hall of GIFs exhibit in the Innovation Studio, the Visualization Studio here in Hill Library, where they basically just take GIFs from the 90s GeoCity sites, and they kind of put them up on the wall for you to look at. And it's just this huge, you know, circular room just full of GIFs as far as the eye can see. And what I kind of took the opportunity to do was make this, I like the little placeholders here. That's actually kind of cool. Take this opportunity to kind of make it into like this like tunnel interactive thing. So let's see. Like you can see this a little bit like with the particulates and stuff. Not the same though. Yeah, that's a little better. Turn the speed down. Turn the jitter way down. Turn the portal size down. Yeah, that's cool. Anyway, see, just to show like, you know, some interactive stuff I could make. But now let's see what else. I do want to show like some other things because there's like a lot of cool stuff you can do inside of TouchDesigner. Let me take a look. Leap motion. Let's see if we have access. Version 2 tracking. Info. as we'll see, because you can use a lot of sensor data inside of TouchDesigner as well. Like you don't have to just stick with, I don't know, like what would I say? You don't have to just stick with like basically what comes in the box, right? Because there's a lot of like data outside of TouchDesigner you can use. I could kind of talk about that, like working with APIs and things. Hold on. Just pulling up an API I was working on. Okay, let's see. I'm gonna download this. Just pulling it up. But no, it's a pretty great application, and we'll probably get into just like building a few more things here in a sec. But I want to show some stuff first. Okay. Venture is an API. Load. Okay. So this one's a little different. This is a more Python-based one. And what I can say about TouchDesigner is that like we've kind of been talking about it in more general terms, like about these operators. But basically each of these operators is a function, you know, for all intents and purposes, or I guess a method if we're inside of Python right now. But each of them kind of works as a function. So like if we have, you know, we go back to this one, we have like the transform right here. Doesn't have anything to power it, so let's just, I don't know, put out a circle. So we have the we have the circle function and we have a transform function. And inside of the function, you have a series of parameters, right? You have radius, you know, rotate. So like you can scale things up and down. Like these are like, you know, the initialized parameters, you know, for your function, basically. And then the transform acts upon, you know, what has been piped into it at this point. So, you know, you can move it around, you know, back and forth, up and down. You can scale it up and down. You can rotate it. Not that that matters too much. Not that that matters too much with the circle, like the rotation. But basically, like you can like make this kind of stuff. But all this is working as a function, and if you expose it, these are the parameters, right? So you could reference it. Let me pull up a text real fast. Text dat. So here's my text field. So I can go in here and start like writing. So if I wanted to reference, like let's say this tx function right here, this tx parameter of the node, what I would say is first I would call the specific node I wanted. So that'd be op transform1, the string that's the name. And then from there, I know I'm calling a parameter, so I want to say .par. And then whatever one I want to grab. So if I was going to grab the ty value of it, I would say .par.ty. And that is how I've referenced that in TouchDesigner. So now I've exposed this. This is, you know, just like Python notation that I can use anywhere else, you know, to drive other events like through code. And that's kind of what I wanted to talk about with this one, is that this is basically drawing from a web API, and it's organizing the stuff into tables. The API I was using for this, let me jump back, is this quotable.io. You should check it out. It just generates many quotes, and that's basically what it is, just a huge repository of quotes on an API. But basically, I can import these inside of TouchDesigner. You know, I can draw from it. The examine I don't need. And then I can run scripts right here. So I'm creating a dictionary, a Python dictionary, and I'm fetching it from where I imported it down here. So like in here, on response, you know, the web client, mydict equals json.loads. So we're going to load in the JSON file and we're going to print it over to the count. Let's go see. Which is a variable I've saved somewhere else. And then on that, we're going to use this text2 just as an operation to parse it. So basically all I'm doing for here is I'm just massaging the data into a format that I can use it in a table. So I'm taking the list results, looping it, you know, to look at every field in the list, and then I can just basically put them in a format, basically parse them into a format that TouchDesigner can use and I can read. So if I get that, I output this big thing of text. So basically we've just pulled out 20 quotes kind of just off it, and we've pulled out the author as well, and we can reference them. Then I can throw these in a table, something like this, And then I basically have access to them if I wanted to make something like a text field. So if I go back to top and say text, you have this dat option. So I could say null 1. And then let me see if I can scale this to some place where you can see it. Font size. See, autofit. Yeah, and it's basically pulling that first field. We can do stuff like translate it too. And you look, and I can see the row and the column. So basically what I can do is I can flip through all of these and generate this text as a text file. Word wrap, let's turn that on. Derivative, love it. Because we gotta get rid of the text right here. All right, cool. So now what I have basically is a way of rendering out all the text and the quotes I pulled out of this API. And as I cycle through, you can see that I'm basically cycling through all the quotes in my table. And I could make the table bigger. I could call 100. I could call 1,000, via the API. And then I could do something like reference it, I could instance this text onto things. So it's just something to kind of keep in mind as you go through things. And then it's like, I don't know, let's see if we can render this on a shape. So let's pull out a cylinder or a sphere. And a material. Haven't used a material yet. Constant. And then we'll use this to drive the color map. Whoops. Say a null. Make a geo. Actually, let's make a null first. Make a null. Use that to create a geo. Geos are in comps, not sops, even if you think they should be. Okay. Sorry if my ping jumped in there. Let's mute this. Okay. We can apply this constant to it. Material. We can create a map on here. Maybe we change this to, well, it doesn't really matter, right? Because we're going to drive it in here. Maybe put a background on it. Insert operator. Because right now it's just really cool. I think it'll probably just automatically pre-comp the alpha out, but it might not. It might get like some just floating text out in space. So we can use this to drive the color map. Look at null 2. So yeah, so I went ahead and pre-comped it like I thought. Okay, so we got this. Maybe we can scale it down a little bit on here. Pardon me. So maybe insert a transform. Scale it down a bit. Okay. All right, cool. So we have this on the ball, and this is like a little bit of a wild example, I feel like, but it kind of gives a good idea of how much stuff you can get into inside of TouchDesigner. Let's drop this down real fast. All right, cool. Then we'll take a look, and then what we're going to do here. They're basically just going to flip through this. Take the lock off, unlock. Okay. So you see that we've got this dat row right here. Basically just going to keep going through this until we get to like 20. Maybe 19. I think I pulled 20 rows. Yeah, okay. So to do this, not this one. To do this, we're going to make some chops. We're going to say constant. Turn this to 1. This one is right here. We get a count. Actually, let's do something different. Let's make it a little more interactive. Let's say keyboard. keyboard in, take a count. So this is for the 1 key. Every time I hit it, see it's going to flip through and it's going to keep that memory. We're going to say that the count limit is going to be a loop min max. We're going to go 0 to 19. You might see where I'm going with this. So if we go through, we're lost. 19, we're back to 0. We start again. Okay. And now we can use this to drive our dat row field. We're getting there. OP. Count 1. Well, we probably should see. You should use a null. I don't think we'll need to for this, but this is a prime example of like when you should use nulls. Anytime you like reference out, because you may need to change it or insert like a new operator in here. So it's best practice. Best practice to use a null. So we'll say OP count null 4. And then, so you can do this, you can reference this a number of ways. You can reference it as K1, like as a string, but there's only one channel, so I usually just hit 0. So 0. So now, you see, as we hit the 1 key, we're going to skip through. And then we're never going to run out because it's always going to cycle us back around to 0 and we go through. And now we can take our render. Oops, sorry, we're in channel still. Take our render. Not 2 renders, so get rid of that. Add a camera. And a light. Oh, we don't need a light actually because it's a constant. Okay, since this is a little bigger, let's turn up the resolution here. I think we can also go 256. Nah, we're gonna go 1024 by 1024. Then we can really go bigger. So we'll scale this up. Make sure. Should be following use input. I just want to make sure. Okay. Shouldn't be going off the side though, if we're doing it this way. One sec. Probably from the transform actually. Yeah. So we'll bring up the font because then we can word wrap this rather than just scaling it. So font size. Okay. All right, so now we have nice crisp text. We can stay here. And we're going to rotate the sphere, I think. Transform. Okay. So to do that, rotate on the y-axis. Abs time dot seconds times, say point seconds times, I don't know, 0.5. Actually, that's very slow. You forget, when you're rotating, you're using degrees. You're not scaling by 1s, 2s, or 3s. So you have to actually go pretty high. You want to go 10 degrees a second. Okay, cool. Go through here. All right. So now what we can see through. It'd be cool if we could see them all the way through, but they're coming around. Maybe go a little bit faster. Always warp back around. Maybe something like 30. Yeah. So now what we've created. Actually, let's not do this on a sphere. We're gonna lose it constantly. Let's make it a grid. We'll deform it in a second. Let's also stop rotating it. So let's just say 0. Okay. So we'll add a noise on there here too. We are well on our way to making a weird art installation. Okay, perfect. I'm gonna make this a little bigger. Uniform scale up. All right, here we go. So now we have that we've made in just like the last few minutes. We have our flip through interactive quote generator that is being driven by an API that's pulling in quotes from, what is it, quotable.io? I'm trying to remember. Yeah, quotable.io, this API. So we're generating all this from the API, and then we are projecting it onto a texture from here that we can modify by cycling through the table that we brought it in by hitting the 1 key. Which, so if we put that into practice, well, the first one was pretty short actually. Maybe we should scale out a bit. Turn that scale down a little bit, we'll fit it in. Okay. We just cycle through. So now you have many quotes that you can flip through interactively as they're deformed in front of you. So, you know, take this, project it on a wall, like you've made some pretty interesting interactive art, I guess you could say. But like, I guess this like is another like just a summation of what I love about TouchDesigner and like kind of what you can do with it, you know, like what you can make with it. It's just that there's like so many ways that you can change this up or modify it, or have something else drive it, you know, and like again, this could be used for anything, right? I could project this onto a wall. Like I could make something with it. So it's just, TouchDesigner gives you a lot of potential to do stuff. I could take these and I could instance them. Like I could make instancing out of all these quotes, you know, and basically use that to drive, like, you know, kind of some installation, like that particle display I had earlier. Like I could have this field of quotes, you know, like coming at you out of it. So yeah, there's just a lot of possibilities. So just wanted to kind of showcase that. I could take this noise and I could really jack it up, you know. Wow, that's kind of wild. I see, because that's like the thing. I was wondering. You know, like, look at this stuff. You can do all kinds of stuff. Take the grid. And a bunch more divisions. Like, what is this? I don't know. But it does look cool. Yeah, TouchDesigner is also very good for making glitch art if that's your jam. if you want to make things look glitchy, you're in the right place. I don't know if like that's my big thing, but it is kind of cool to see some of this stuff. Oh yeah, it was the period. That was what was really dragging us down. Oh, don't need the seed. The seed's fine. Yeah, very wavery. Smooth that out a little bit, because like the harmonics are, you know, what generates all the noise inside of the noise. You know, like all the like static inside the noise, I guess I should say. So you can turn it down, make it really good. Turn it up, make it really smooth. You know, get some really nice deformations. Turn up the amplitude so they really deform. They're clipping through the camera sometimes now. You know, turn it down. Barely moving at all, just a little deformation. You know, offset, bring it forward, take it back. You know, it's just very interesting what you can do, like, and make with it. And of course, you can always just find a new quote. Like, there's lots of quotes in here, right? So, again, you know, just kind of like an idea of the things that you can do inside of TouchDesigner, like basically what you're doing up in here. Big program, lots of possibilities. So we can also move to something else now, but just to show that like what you can kind of do with data inside of TouchDesigner, you know, to drive things. And this like kind of text API is just, this quote text API is just kind of scraping the bottom of the barrel. Like this is just the surface right here, the surface level. So I just wanted to show that. I could make something new. I'm going to quit that. Let's see what else. I also want to make sure I don't want to pull something else up. 1 second. So just looking in my documents real fast. Just want to make sure I don't have something that like I really want to show that I'm just missing out on. Let's see. There's just a lot of cool stuff. A lot of cool stuff to talk about. Okay. No, most of this is like looking pretty good. Something I should talk about, I guess, like when you're making things inside of TouchDesigner, is that this won't be as much of a practical, like fun example, but this will be kind of like a showcase, like in kind of like what you can do with it. So by default, I would say TouchDesigner doesn't have the best rendering engine, right? Like it doesn't have the best 3D lighting and things like that. But it is very easy to output data from TouchDesigner into other applications. So kind of what I mean by that is that I could go to this chop channel. I could say OSC out. And if you're not familiar with OSC, it stands for Open Sound Control. And basically it's used to transmit channel data, usually from an instrument or a MIDI controller, across devices to move it to something else, whether that's like another controller, a computer, things like that. So again, mostly used in audio is kind of the thing. But TouchDesigner is very good at making anything into channel data, right? So like, let me grab a circle. Again, we'll go back to it. All right, so I have a circle here, but it's not just a circle. Not that one. It's not just a circle. It is a chop. It's got channel data. You know, like I can put this circle through a MIDI channel, you know, and bring it into a music application, like as a sound or something. But what I can also do is I can use this just as a data stream, and I can send it to something like Unity or Unreal Engine, or anything that, you know, accepts OSC data, and I can just run this through it, right? So like, just plug that in. You know, here we go. And then maybe like I animate it, like for the radius. ABS time, dot seconds. And it's already animated it, actually, if you see. Oops. Well, we can grab some other stuff too, as we'll see. This is just going to fill the world, actually. We can go beyond. I think actually more so than ABS time dot seconds. Let's not do that, because that's just going to increase it forever. I think what we really want to do is put like another oscillator on there or some noise. So go back down, make a smaller circle. 0.2. Okay, there we go. So like if I drive the translation of this with an LFO, so LFO, always going back to LFOs, math, and the math node is like super useful inside of TouchDesigner. Basically what you're doing is you're taking a value, in this case a value oscillating between -1 and 1, and you're just remapping it to something that's more useful to you. Because if I plug this in as is to my translation here, let's say, so OP null 2, not JOP, JOP, null 2, then channel 0. Got that. Null 1, sorry. Can't read. There we go. Alright, there we go. It's actually not too bad because it's inverting itself and you can't tell. Sometimes like it would just, if it was a 3D object, you would just see it like explode on itself or be completely grayed out. But basically, as you look at that, we have now converted our circle image, this rapidly resizing circle image, into a channel that's just basically going on, off, right? Like it's a Boolean 0, 1, 0, 1, 0, 1 every time. Just kind of based on like this time map right here. Because all we're doing is plotting the point values, you know, the RGB point values against it to the point it's looking at. So yeah, I mean like the pixel values that make up that circle. So basically, and then what's in here is the values, right? So you have this very, can we slow this down? Let's slow this down. It's going very fast right now. Okay, there we go. That should work. So what does this look like? So you'll notice it's basically counting the values of the pixels in the bitmap right here. So 256 by 256. So on here, you can see that we go up to 256. And then as it goes from 0, which is no color on it, to white, which is one color, especially on this alpha, you can see it. They're all the same right now, but you know what I mean. It's basically moving from 0 to 1 in the areas where it doesn't have it. So when it's in its smallest form, you can see that it crosses each other in the middle before spreading back out to the sides. So all that bitmap data that we've represented as a circle is now being converted into channel data that can go out through OSC. And anything that can accept OSC data, what I use it most often is game engines, can now use this to drive anything in that game engine, right? So like if I had a nicely rendered sphere inside Unreal, for example, I can now scale and translate it based on whatever I did to it over here. And this is a kind of a bad example because I could just throw an LFO on it, inside of Unreal. But I could also like use camera data, inside of TouchDesigner and send it over. I could use, like Arduino data. Like I could put a sensor on an Arduino and then use that to drive it. So it just kind of starts opening your mind up to some of the possibilities, when you're working with this stuff. And this is just a really good one to kind of show that how easy it is to send data in and out through TouchDesigner. And I could do the same thing the other way, right? Like I could do OSC in. Like I could turn TouchDesigner into an OSC receiver right here. And then I could just choose the port that it's coming in from, and then whatever info, like if I wanted to get info back, from Unreal, I could do it that way too. So like the two, now basically I've linked up these two very separate programs to talk to each other and basically work together to create something greater than the sum of their parts. So just to showcase kind of what you can do with TouchDesigner, I just want to see something real fast. Active channels. Yeah, 0 to 255 if you want more range. Not a pixel. I want rows and columns. Yeah, if you do it this way, I don't know if you can see it, like over here now that you're doing it, but now I have every pixel in the entire image separated out. So if you look at this, pardon me. So if I look up top, it's not always doing something. So basically what you can see is what I've done here is like each one of these is a set of pixel coordinates to show like where it is in the world. And if once you get to a certain point, you'll notice these aren't doing anything. And the reason why is because we're looking at ones up here or down here where there is no like deformation. They're just going to stay, solid the entire time. So we're just like looking through, and then there'll probably be another one down here. Once we get down here at the bottom, it'll probably start again. No, maybe not. Maybe it's all clustered up top. But just like to show, basically that you can, map all of this stuff, like no matter what it is. I could do the same exact thing with a 3D object, but you can map all of this against channels and convert everything into channels. And you can do it the other way around too, right? Like I could go back and grab, that audio file again. I could take that and I can convert it into a top first, not a viewer, sorry. Could convert it into a top, jump to top, and then you see that we're generating this noise across the frequency based on whether it's 0 or 1, and like we can choose a data format R, RGBA, well, not A, there's only 2 channels on here. 2 channels. I think it's going to throw an error if I do B2. Yeah, because we only have 2 channels of data. If we had 3, we could do all these. We could map each of them to their own channel. We could make wildly different kinds of data mapped across an RGB color one, because we would just be merging different sound channels together to create this image. We could make a shape out of it. It'll probably be a line, to be honest, but you could make it. Let's see. TXTYTZ. Yeah, exactly. So we'd have to rename this channel scope. Let's see, chan 1, chan 2. There we go. So now we've mapped them against each other. I love that. I love how that looks. We can zoom out and look around at it too. And it's because since we've mapped 2 dimensions, rather than just getting like a line or something. Oop, zoomed out really far. Also, just might be that it's like kind of. I just want to see real fast. Oh, I lost it. We're going to start over again. Oops, not that one. Sorry, sometimes you have to be precise with your clicks. And it gets cold up in the streaming studio, so sometimes like near the end my fingers just start getting really clumsy. Okay. Sop. Chop to sop. And again, we'll need to change the frequency to Chan 1, Chan 2. There you go. And then you can like see that. And it's distorting across 2 dimensions, right? So you have like, rather than just a point, you have a line. I think we could take one of these out too and just be like, yeah, so you just have a line distorting right here, which is not very interesting, but like it is something you can do. Let's say Chan 2. And we can grab another audio file. Audio file in. Let's change the audio track to something different. So we have this other audio track. Then we'll say select, because we only need one more, right? So we'll call it Chan 1. So we'll grab that. We're going to rename that to Chan 3. Could be anything, but this works for our purposes. And then we're going to take this and merge. Oh, one there. One there. Now we got 3 channels, right? And then we're going to take, we'll output a null. This is why you output nulls, right? Because we need to now rename the one we're doing. So we'll output a null, null 2. I'll actually just get rid of this one. And we'll convert this. Chop to sop. Chan 1. Oops. Chan 2. Chan 3. Now, although I don't know if you can see it, now it's deforming in 3 dimensions with it, because before we were just going kind of 2D, now we're going forwards and backwards as well. Pushing it out. Yeah, that's kind of wild. And again, it depends, because this green one actually is very small, so we actually might want to even massage that a little bit. So the select one might run it through a math, right? Because we're going from like what, 0 to 0.1. That's super small. So we'll say 0 to 0.1 is now equal to, 0 to 1. Like we're kind of getting something bigger. But we can make it much bigger. So we can go from like 0 to 5. Or something like that. Sometimes you get these big snaps, right? Because we've changed it. And then you really kind of see the 3-dimensionality of it as it goes across the screen. And you can render this out too. Like you can convert this into a geometry. Make sure you're in the comp tab. You can just slap a render on that. It's not working now because you need a camera, a light. You can see it kind of starts with the camera right there, right? A light to light up your spaghetti kind of explosion thing. And then you can put a texture on it too if you want, like a material. So if we wanted, we just add a constant. If you have a constant, you don't need a light. Constant means that it's constantly illuminating. We could make this like red, or something. And boom, there you go. Like things like that. And then if you wanted to, you could just composite multiple renders on top of each other. Like translate them around and stuff like that. So you could even take them from different directions, because we're just looking at one camera view right now. So grab another camera. Let's look at it from here. Okay. Grab another render. So like this, so we just need to define that, no, we just want Geo2. The camera is Cam2. No, we actually want Geo1. Sorry, Geo1, Cam2. So now we just have two views, right? So we can just take the two of these, and we can just composite them against each other, right? Composite your renders. It's like there's no other thing. Boom. Don't use multiply though. We're gonna use add or on top. So now you see we're running the effects of them against each other, right? And getting this kind of thing, right? So you've got a very angry audio visualization, you know, like now on your screen that's being driven by just a constant. And if we wanted to change this, we could actually delete that, make something like a fong, just to show. You see now it's reacting to the light too. So if we move the light around, it's going to be more or less illuminated depending on where the light is. Like, so that's pretty good. And if we put down a plane, a grid, let's put some geo. You can start getting shadows too against it. So I only need one shadow render. So let's go here. We'll move it back a little bit. And then I'll put some shadows on the lights. Shadows on. There you go. Maybe slide the grid back a little bit. So center, what are we on? The z-axis, maybe? So bring this back, take it back. Yeah, and then you can kind of see those shadows like across the surface, as long as your light's in the right place. Yep. And then, like at some point, you could even turn off the renders themselves, like the images, and just leave the shadows. But like I said, we're getting a little too into it now. But just to show some of the cool things you can do, you can turn these different colors. You know, same as that, same as anything. Let's make something. Let's go with like purple fuchsia. That really shows the difference, right? Because now you see both the, you know, deforming lines and then the shadows that are being generated at the same time. Because it's 3D, right? It's a 3D scene. But it's just a 3D visualization of these audio tracks going nuts against each other, like in three-dimensional space. So the whole point was just to say that you can convert anything to anything inside of TouchDesigner and get some, you know, crazy or interesting results. Just to show that. That's kind of what the whole spiel was at this point. I've got like maybe 20 more minutes, so maybe we'll look at do one more example. I was trying to think something that might be fun to do. Kind of how to build stuff. How do I think about stuff? If you wanted to get started learning TouchDesigner like on your own, like I guess I kind of left that till the end a little bit, but there's a lot of good resources out there. Actually, maybe this is just like show and tell time. Hold on. I think I'm just gonna throw this up here. Make sure I can see everything. Make sure I can see my browser and everything too. Yep. All right. Cool. We got it. So YouTube is where I'd start. Don't want to show too much again because we don't want to get like sued or anything. see. Yeah. Sorry. What do you think? Bliam Jeshby? I probably butchered that, but he was a German student working with like audiovisual production. And I think now he works for TouchDesigner, but basically his whole thing was just developing TouchDesigner tutorials. I'll try not to get any sound bites here so we don't get our video taken down. But basically, if you look through the stuff he's making, these are just all great freeform tutorials that you can take a look at, you know, that just give you so many things that you can do inside of TouchDesigner because it's such a versatile software and like just like all kinds of things. What are going like generative shapes, super good. Drawing with texture instancing. Anything with texture instancing is super cool. Like reactivity, you know, he has like one on like playing drums with like a Kinect controller, just like moving through infinite space. You might have seen that earlier. That was definitely one of his tutorials. Like I tweaked it a little bit, but yeah, you can see it. Make anything audio reactive if you're interested in making audio visualizations, like super good. So definitely a good place I would point people. The other one, Nodo, the talking ball. Shout out. Probably the cutest tutorial site I've ever seen. Turn that off. Sorry if I blew you out. The computer just loaded too fast. But basically, see, I believe he's an audiovisual artist. It's like English is not his first language, but I think that adds kind of to the effect. And he apologizes fairly often for any kind of errors or things like that. But if you check out his tutorials as well, you've also got a lot of really great stuff inside of there. That liquid paint effect from the beginning was taken from one of his tutorials. And between the two of them, you should have like a really good, solid foundation. Also, this is adorable. You should check this out just to see it if you want to. But basically, yeah, I would look at these two resources for tutorials. Check them out. They're really good if you wanted to get started learning. Trying to think anything. Oh, the other one is the immersive and interactive, which is kind of TouchDesigner's. I don't know if they're like official channel. I think it kind of is. The interactive and immersive HQ. And basically, we'll pull this up real fast. Ugh, sorry if I'm blowing you out there. I'm just trying to skip through. But basically, this is just a huge number of TouchDesigner tutorials. In some ways, it's too many, but it's just like everything that you want to know or you can think of, you can find here. So this is another good resource, although I'd probably start with the first two that I recommended if you're a beginner. But there's just a huge volume of tutorials here that they put out. I believe this is kind of like Derivatives official. So just to give some examples on like how do you get started learning. If you didn't want to look up tutorials, like if that's not your thing, I would just get started with a couple of things. So first, maybe start with tops or sops, unless you have like an audio background, and then in which case, yeah, by all means, jump in with chops, jump in with what you're familiar with. But from here, just to show you like how to get to documentation and stuff like that, if you're trying to create things in TouchDesigner, you can go to things like, I don't know, let's like make a noise. So much in TouchDesigner is just derived from noise, so let's go to start here. But if you look over here, you have your parameter feature on the side, which gives you all like the outputs you can use across things. Usually the first few are unique to it, like the noise transform, and the common one is on almost all parameters. But up at the top here, first off, if you hover over stuff, oops, and hold the Alt key, I don't know if you can see that. I can't really zoom in on it because it's an overlay. But if you hold the Alt key, it's going to give you a detailed description of everything the parameter does. And you can just kind of pull it through all of them. And if you need a little bit more than that, you can click these links. This one will take you to the node parameters page directly inside of the help. You can't see it because it popped over in the screen. But pull it up here, and it'll bring you straight to TouchDesigner Derivatives Wiki, which will basically walk you through all the parameters, the different types on every page and what they're used for. So it's a really great resource. And then if you are into coding, like I said, basically all of these things are methods or classes inside of Python. It'll basically give you all the parameter values that you can interact with, all the methods inside of it that you can interact with, and basically how you can write to this in any kind of situation. And then, like it says, it has the inheritance, hierarchies. So right here, you can say, if you just want something that applies to like all of the top class members, all the texture operators, you'll find like all the methods, all the calls, all the functions, all the flags, like all in here to code with. And this is just a great, great, great resource. They really made it easy to dive into this and really learn. So just know that you can look at that. In general, I would just start messing with things, seeing how they shake out. I would say to learn a few simple scripts, even if you're not really into scripting, because this one right here is just worth so much. This ABS time.seconds times, we'll say 0.5, 0.4. But basically, this is what's going to add motion, and interaction and animation to your things when you're starting out. Just this simple script. All it's doing is incrementing this through the timeline, and it's absolute time. You can do relative time too, so like it would reset every time the timeline, jumped back around. Right now we're doing 600 frames, but absolute time counts how many frames have started since you opened the document, like since you hit play on the document. Like if you stop it, oh man, no. If you stop it, it just keeps going. Like it's just going to jump to where the next point is. So from when you open the document, it's just going to be counting that time down, and you'll always be in the same place. And the nice thing about this, let's bring this up here, is that if you make two separate ones, and you're like, okay, well, I want to link up their time, ABS time.seconds, and then what was this at? Times 0.5, I think. Let's see. 0.4, that makes sense because they're not synced up. Okay. Times 0.4. If you put these side by side, they're exactly the same, like if you look at it. And it's because they're both running off that absolute time value. And this is really useful. Like if you need to make things tile or like line them up or things like that, you always know exactly where you are in the timeline, and your things are going to deform exactly the same way. Now, if you want to get around that, almost all these things have a seed function. So like now I've got a different seed, and no, it's not the same, right? Because it's just some other seed that I'm generating from. But you can always push it back to the same one, and then everything suddenly syncs up again. So just something to know. Keep in mind of that ABS time.seconds times whatever the value you want. I mean, like if you leave it alone, it'll just be the default, but that may be too fast or slow. So, just multiply it times whatever you need. Times 5, real fast. Time 0.01. Yeah, that's really slow. Okay, I don't even know if I can tell really. 0.1. I wonder what the breakpoint is. 0.05. Yeah, you can tell it's moving. So like, you'll use this time and time again, basically to generate movement and animation kind of inside your stuff. From there, just kind of plug things into each other, see what looks good. There are definitely some of these nodes that I use more often than others, but you'll kind of just get a feel from them from following tutorials and seeing what other people use. Feedback is always very fun if you know what you're doing with it. Let's say like a null. We can break this one. Disconnect. Feedback is looking at null 1. Oh no, it disappeared. And then we will do a distort, or what is it? Displace. Displace is also very fun. I'll just copy this. This is similar to what we made early on. I'm just going to make this real fast. Doop. Okay. And we're going to, I want to pulse this real fast. Ooh, I love it. It's a little too fast. Feedback's fun. Like I said, you can get a lot out of feedback. Let me push this up a little bit faster. Okay. Pulse. I need to do levels. We're almost out of time, but I just want to kind of finish things up with something. It's not not level, what is it? No, it's level, just not levels. Post, opacity, bring that down, pulse, cool, and then turn the displace way down. Love it, so good. Displace weight, yeah, 0.01. 0.01. Okay, cool. But you could do things like make feedback loops and stuff like that. So, you know, like pretty similar to what I was doing. If you can't tell what this is doing, like, you know, real light, you can see it kind of displacing and waving like the thing I had earlier. And I can also increase that amount. Right now it's pretty subtle. Something like this. Yeah, looks good. I love it. Anyway, feedback loops, fun. Texture operators are fun. You know, just kind of find something that you're interested in and kind of run with it, because TouchDesigner is great and should be explored, and you could do so much with it. So I think I'll go ahead and put a wrap on it for tonight. Thank you so much for tuning in. Thank you for checking out TouchDesigner with me. It was a blast. I always love talking about this software. I'd love to talk about it again. So thank you, everyone. Have a good one.